Hello everyone, I'm Singh Gambhir, third year student at Hello everyone, I'm Singh Gambhir, third year student at IIIT Allahabad. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, this is one-stop destination for you. Every week we will be posting explanations to CodeChef problems, conceptual videos, and also conduct live problem solving session. Before we actually get started, make sure to hit the subscribe button. Also, did you know that CodeChef also conduct free live classes on an academy where we teach every possible topic related to competitive programming. These courses are conducted by top coding experts who have been ICPC World finalists and are also highly rated on various coding websites. You can use my referral code MEET10 to subscribe and get an instant 10% off. Today, we have a problem named hiring test, which is a simple level problem based on implementation. So let us see the problem statement for the hiring test question. Now, a company conducted a coding test to hire candidates. N candidates appear for the test and each of them faced M problems. Each problem was either unsolved by the candidate, denoted by U, solved partially, which will be denoted by P, or it could be solved completely, which will be denoted by F. Now, in order to pass the test, each candidate needs to either solve X or more problems completely or solve X minus 1 problems completely and Y or more problems partially. So, in order to pass the test, which is conducted by N candidates, where each of the candidates will have in total M problems, there are two possible conditions. The first one is that either a candidate solve X or more problems completely, then also he would pass the test. Or the other condition is that if he could be able to solve X minus 1 problems completely and Y or more problems partially at the same time as well. Now, given the above specification as input, print a line containing n integers. The ith integer should be 1 if the ith candidate has passed the test, else it should be 0. So if either of these two conditions follow, then we need to output 1 as the answer for that particular candidate. And as we have in total n candidate, so we will be printing a line which has n integers. And if the candidate is not able to fit in any of these two criteria, then obviously he would fall into the category of the fails one. So we need to print 0 for that test case. Let us see sample test cases for this particular question. Now in the first line of the input we have test case, and when it comes on to each of the test case, we have firstly the number n, which represents that how many candidates are there which are giving the test. The second integer from the first line itself, it is nothing but the integer m, which represents how many problems are there in the coding test. The second line, it will represent the number x and y that are used in the question as well. Then there would be n lines where each of the line would have m characters, where if the character is f, it means that that particular question is being solved fully. Similarly, p is for partial and u is for unsolved. Now we need to determine that either this particular candidate, it falls in either of the two categories or not. So if you talk about this particular question, then the two cases will be that the first one is that the number of fully solved questions is greater than or equals to x, or the second condition is that the number of fully solved questions would equals to x minus 1 and the number of partially solved question should be greater than or equals to 1. So this is also a constructive problem itself. So what we will do, we will start for each of the candidate and check that out of the m problems which we have for that candidate, either these two conditions are satisfied or not. So if we talk about the first candidate, then he has solved fully 3 questions and partially 1 question. Even if we do not count how many questions are unsolved, it doesn't matter because we do not require that to calculate our answer. So as you can see here that the number of fully solved question for the first candidate are greater than equals to x, because we have 3 as the fully solved problems by the first candidate, and also the value of x is also 3. So we have the condition 3 is greater than or equal to 3. So this particular candidate falls in our first category. And as the answer in both of the category is yes only, so we need to add 1 in our answer for this particular candidate. Let us see what we have for the second candidate. So if you calculate that how many fully and partially problems are being solved by this candidate, then we have that the number of fully solved problems are 2 and the number of partially solved problems are also 2. So if you check for this particular candidate, does it falls in the first category or not? So as the number of fully solved problems are 2, which is not greater than or equals to 3, so it doesn't fall in our first category. So let us check for the second category. And in the second category, we have that the fully solved problems should be equals to x minus 1. And as we have 2 as the fully solved problem for the second candidate, and x minus 1 is also 2. So there is one more condition that the number of partially solved questions should be greater than or equals to y. And as here the number of partially solved questions are 2, the value of y is also 2. So this condition also holds. So we can see that if we talk about the second candidate, then it falls into second category. And obviously we need to again report 1 as our answer for this particular candidate, because if a candidate falls in either of these two categories, then it is a 1. And if a candidate doesn't falls into any of these two categories, then only we need to output 0 for that candidate. Now we will go on quickly for the third candidate and the fourth one. So the number of fully solved question for this candidate is 2 and the partially solved questions are 1 only. So clearly it is not following the first category, because in the first category we want that number of fully solved problems should be greater than or equals to 3. If we check the second condition, then the number of fully solved problems are equals to x minus 1, but as we also want that partial problem solved should be greater than or equals to y, and as 1 is not greater than or equals to 2, so this particular condition violates. So this candidate 3 doesn't follow into our second category. Now as the first category as well as the second category doesn't fall, so we need to output 0. That is, this particular candidate will fail. Now if we see our output, it will be becoming 1 1 and 0, because our third candidate has failed. Now if you see for the last candidate, then also he has m number of problems, and out of those m, fully solved are 1 and partially solved are 4. So if you see for the last candidate, it also doesn't fall in any of the two categories, because for the first category we want that fully solved problem should be greater than or equals to x, which is not the case. And for the second category, the first condition is only the violating one, that is the number of full problem solved is not equals to x minus 1. So it also doesn't fall in any of these two categories. So he has failed. Now the final answer which is required to be reported, it is become 1100. So let us see the solution for this particular question. Now if you see by the sample test cases only what the approach is. So what we will do, we will iterate for each of the candidate from 1 to n, and we will answer for each of the candidate independently. Now how to calculate the answer? So we just need to count that how many problems are solved fully and how many problems are solved partially by that particular candidate. So we will iterate from 1 to m, where it represents the number of the problem. Now we will calculate how many problems are solved fully by this particular candidate, and as well as how many problems are being solved partially. And if this condition is satisfied, that either number of fully solved problems are greater than equals to x, or we want that number of fully problems solved should be equals to x minus 1, and the number of partially solved problems should be greater than or equals to 1. If any of these two conditions are being satisfied, then we will output 1 for this particular candidate, else we need to output 0. When it comes on to the code implementation, the first variable which we need to take as the input is none other than the number of test case. While iterating for each of the test case, Firstly, we need to take input n, m, x and y, where n represents the number of candidates, m the number of questions, and x and y are the same variables which are used in the question. Now, the main part, which is the logic of the code, comes in. When we are iterating for each of the candidates, we need to have the count for how many questions are being solved fully and partially by this candidate. So for each of the candidate, we have initialized two variables, the first being the full and other being the partial, which will store the value of the number of questions solved fully and partially by the ith candidate respectively. So we need to initialize these two variables as 0 for each of the candidates. So we have put these two variables inside our for loop only. Now we need to iterate for each of the m problems for ith candidate and check the value is f, p or u. So we will take the input in the character form x, and if the value of x comes out to be f, what it means? It means that this particular problem is being solved by our candidate fully. So we need to increase the count of our full variable. Similarly, if the value of x comes out to be p, it means that this particular problem is being solved partially by our candidate. So we need to increase the count for the partial problem solved. Now, when we are completed by iterating all the m problems, we need to check two conditions. What are they? The first one is that the number of full problems solved should be greater than or equals to x, or the number of full problems solved should be equals to x minus 1, satisfying that the partial problems solved are also greater than or equals to 1. Then we will output 1. Also, we need to output this new line at the end of each of the test case. This is main thing, because if you do not do this, then also you would have a wrong answer. So let us submit this code. Have an AC. That's it for this one. Make sure to like the video if you gain something out of it. Do submit your code even after the contest, and in case of any doubt or feedback, feel free to leave in the comments.